Good morning, and today we're going to continue to use the discriminant. So I have a third example here for you, and it's a harder one, as you can imagine, which is why I have separated it from the others. So you can see here it's quite a bit more complicated. So the coefficients are actually a bit more complicated. We've got a 2k plus 4x squared, 3k plus 2x, a k minus 2 equal to 0. So show that this quadratic has real roots for all real values of k. Okay, so let's start with, so we're asked this time to show that it has real roots. So this is a little bit different. We're trying to show in the end that something about this is going to make us realise that this must have had real roots. Okay, so we don't know what to start off with the discriminant, so we're just going to not make it equal to anything or greater than anything or less than anything. We're just going to start off with the discriminant and see where it leads us. So A is equal to 2k plus 4, B is 3k plus 2, C is k minus 2. And let's put that into the discriminant now. Obviously have to be careful because you've got a lot more to deal with this time. So here we have our B squared minus our 4 times A times C. So we have to be very careful when squaring things out. So we square out the bracket and then we've got to multiply the second bracket out as well. So here we have the first bracket squared, square the first term, multiply them together, which is 6k, and then double it, 12k, and then square the last term. So that's the first term squared out there. Then I haven't dealt with the 4 yet, okay? And what I'm going to do is just multiply out this bracket. So we've got 2k squared minus 4k plus 4k and minus 8, and that leads to all of that. And then the next thing I'll do is multiply out by this negative 4 in front of the bracket after we've tidied these together, and then we'll gather all of our terms together here. Okay, so I've just tidied that little bracket at the end there together. The negative 4k plus the 4k has just made it a 0k, which is why the k has disappeared, and then we'll multiply by the negative 4. So be very careful here when you're multiplying by a negative outside a bracket because it's negative 4 times each of the terms. So just watch how each of those terms had changed sign there. Okay, so we gathered our k squareds together and our k's and our constants. So we have a 1k squared, which is just a k squared, plus a 12k plus a 36. Okay, now what you try to do when you're trying to prove something is real or whatever, then we want to factorise it. And k plus 6 all squared is what that would be factorised. K plus 6 times another k plus 6. So it's k plus 6 all squared. Now, if we're trying to show that this has real roots, then we're trying to show that it's greater. The discriminant is greater than or equal to 0, i.e. if it has real roots, then it can't be negative. Because if it has real roots, then it's at the very least it's going to be equal to 0. Or greater than 0, but it cannot be negative. And we can see here now that we have created an expression k plus 6 all squared that can never be negative, because no matter what value of k you put into that bracket, you're going to square it, and if you square it, you will turn any number into a positive. So k plus 6 all squared cannot be negative. So k plus 6 all squared is greater than or equal to 0. And remember, your k plus 6 all squared was your discriminant. So b squared minus 4ac is greater than or equal to 0. So the roots are always real. Now, this is taking the question to a higher degree of difficulty. And as always, ask your teacher for an extra explanation if you are unsure about this. Okay, it is a more difficult question. Okay. So we're now on to some other questions in exercise 8i, the same exercise, but we have a different selection. If we can get to 5 up to 8, if we have time, that would be great for extra practice as well. Okay, and remember, ask your teacher for the extra help, and take care and good luck.